Okay, can we start now?
Yes, please.
Hello, teacher. So today we will use function. We will use some basic function of Python to make a new function. So why we have to make a new function? Because some work is not enough to use the tools to perform the work, your work. So we have to use some basic function to make the new function that we can use in the big model. So first on, what is the function? Uh, could you define me what is the function? Mr. Cường, Dr. Cường.
So for a function, we have an input in the respective output. So we have a domain space and we have the image space. So we have the flexibility to choose what kind of space we want. So that's the definition of function in my understanding.
Okay, very good. So very detailed. So, but we don't need more detail like it. We just define it's a general form of variables that we can substitute the variable and we can get the exact value. Now we can use. Okay, now we can start now. Collab. You can follow me. Collab feature google.com here. It's available here. I can skip it. And we cancel and we can choose a new one. Okay, let's start from the first symbol, the simplest function. We use define def. Use def to define the function. For example, we can define a size function of x of variable f here, and we will return the value of maybe to multiply by size x. Here is the symbol assembly function that we can record now run. It may be slow for the first one. Okay, now we can use this function, the function side function, to perform the solution here, to perform the function there. Result. Function here is maybe we will call size when yeah, it's also appear. We will replace x by another value, for example, 2 decimal 0.5. Okay, let's put that. Not defined, so we need to define the because you have to use the library. New library is import numpy. Okay, here is the library. It's so useful. Numpy library. Here's the new library for us. Here is numpy. You can follow this. It will support NumPy is NP. Sounds up here. And we use it for NP to call side function, because in side function is one of the function in NumPy library here. Okay, we can call the function and replace x by other function. You can other values of x, and you can calculate the function. Here is the simplest form of the function. Okay, now we can use another function. For example, here the graph. Okay, let's try. Because we usually draw graph, so we can define the function is draw graph. Right up. Maybe we just need x and y here, and we also use a library in Matplotlib. So we have to import Matplotlib. And here is plt plot x and y. We plot it plt x and y. We could put marker to set the color of, maybe could get the orange here. And plt, we can follow here. You can follow this. Let's try on your computer. And plt. It's label here. It's set for x-axis. Here label. Here is x-axis. Okay, and here is plt for y-axis, y label here. Y-axis. And we can put the title or legend, but the legend is for specific function, so we don't need to put in legend here. PLG title. Could put the title here. Here is the title is the function performance, maybe. And remember to put so, PLT so. Okay, here is the function of raw graph. Now we use this function to draw quadratic. Okay. Now we draw quadratic. So we set x value here, x value here. Some values of x here is a rate of maybe -3, -2, -1, 0, 1, 2, 3. Okay. And we get this. We will combine the values. If function, if, and for collapse here, for loop here, or s in x value, and we will calculate x by the function here. We to x power of 2 here, minus 2x plus 1. Okay, now we will print it. For the brackets in the quotes like this, in symbol quotes like this, and here brackets here. The first bracket we show the first position of the value of x. It also run here, and the y value is put in the bracket. This mean is the second function at the second column of performance. And format here is the function for the first value, and the second value is x and y. Okay, we can bring it. Yeah. Zero here, this a symbol we can put in the quotes. A simple quotes but it's not a string. It's not a string. It's the position. Zero is the position, and number one is the second place, and the second column. And we can, if we want to write, so we have to put y value. For the first values is empty. We can put here values is empty. And now we will add on the values on the value of y corresponding to x values in y values. So we can use append or values. Append. That means you will add x value here. Append y. And then we use ref. I remember to put so ref here. Ref. Now we call the function the above function ref. Ref of x values and y values. Yeah. Okay. Now we can show this. Here is the function. Okay, here is the symbol function that we can call it for the big model or the big for your working. It's useful. Okay, and the next one is, in this session, I'd like you to understand the use of the function and some symbol and some basic function in the library. Okay, now we can use it for the second derivative. Yeah, now we can use def for diff2. It means it is second derivative of function f and y, f and s and h. Yeah. Now we will return the values of, here is the ratio of f s minus h to minus here x. That's okay. Here we can divide. Here is the derivative of the definition of a derivative, the second derivative. So we can put in a bracket like this. Okay, here is the function for second derivative. Now we will use this for my work. Is a print reset error. Now we use the function for the left is for k in range. Range is the values if in the interval of the value will get from 4, maybe from 4 to 8, 4 to 3, 4, 5, 8. And we will calculate 8. Maybe 8 is okay here. We set the value of 8, and second derivative here is f2. We will use the function here, the second derivative, the function we define before. Use this f2 here. And now we use, because the function existing variable s and h, so we have to use the lambda function. It look like Sims. I think it look like Sims in MATLAB. The same meaning. Lambda to set x is the variable of the function. Now we can put a function in x. And that's 6. And we can use here the second variable es, so we can put x here is 1 and 8. We can keep it. Now we can check the error. We check the error by diff2, by df2. df2. Maybe the error we will subtract to the integer part. Integer part here is 45. I remember that. Okay, we can use it. Print. In this section, we also use the new function. Also, here is percent. Percent is also the function that's locate for the first column. We can put the number to leave the space. For example, with 2, 3, or 5, we can leave it like this. The second one is performed in E. Maybe for some error, it's also the big error. And number 10 here is mean the space. Maybe it's 10 centimeter for the between the first column and the second column. And number 5 here is number 5f, like this. 5f, this means it's 5 decimal. 5 decimal. Sorry, we can continue here. Okay, here it put for the third column, we can put 7 decimal here. Is the space of the second column and the third column here. F 6f, that means a 6 decimal after that. Corresponding to the value of x, the f2, and the error. We show this. Okay, here is the space. The space is 10. This space is 10. And decimal is number 5 here. 5 decimal. And here is 6 decimal. And the first numbers for the space here. somewhere for you can check. Okay, can you define for me as a next definition here is define. Can you help me to define? Let's define the function for calculating mean of the sequence. Mean of the sequence. Okay, you can try. 3 minutes. You can divide for the function to calculate the mean of the sequence of any sequence. For example, I give you the sequence like this.
Anh Tuấn ơi, em bị theo không kịp rồi anh ấy, em đánh lại cái file cái lệnh thứ 10 của anh đó, nhưng mà bên cái phần máy của em nó bị chạy, bị báo bị lỗi anh.
Đánh nó lỗi sao thầy có thể cho anh xem được không?
Để em show coi làm cách nào show đây.
Thầy chụp hơn hay là thầy share screen cũng được.
Để em gửi mà em gửi trong chat box mình có gửi.
Chatbot nhiều khi nó chạy chữ cho nên không phát hiện được nha.
Để em xem coi có gửi hình được không.
Chấp nhớ là thầy chụp điện thoại được không?
Tuấn ơi Tuấn, nhờ Tuấn copy cái đoạn lệnh số 10 vô chat thì mọi người copy cho nhanh.
Dạ.
Lỗi nhanh.
Em gửi cái hình đó
Thì chạy thử để hiểu.
Với lại cái lệnh ở phía trên đó, lúc nãy em theo không có kịp anh, cái phần mà vẽ cái parabol đó anh.
Rồi ok. Để come back rồi.
Dạ anh back cái đó lại giúp em.
Graph here. Thầy có chụp được không? Thì có chụp được cái màn hình của thầy đang xài không? Đang làm không?
Em gửi trong chat box rồi anh.
Để xem thử. Ok. Chưa thấy thầy.
Em chưa gửi qua sao? Để em xem lại. Chat box đâu rồi? Em chụp rồi mà em chưa có gửi đi.
Rồi. Thấy rồi đó. Để xem báo lỗi gì. Int. Integer. Hay là ở trên thầy chưa define? Ở trên thầy chưa định nghĩa nó phải không?
Để em xem.
Tại vì cái này là cái thai đó, thầy thêm chữ in vào chứ. Int diff. In diff to cái diff đó thầy gọi bị nhầm rồi. Cái diff sau á, cái df á, thầy thấy chưa thầy nhá? Cái df á, cái error đó là phải là cái kết quả của df2 trừ 42. Còn ở đó thầy lấy cái function ở trên thì đưa xuống, cho nên là nó báo lỗi cái int rồi.
Ok dạ được rồi anh. Dạ.
Đúng rồi. Cái function này thầy kỳ theo không kịp hả? Cái phần ra
lúc nãy em gõ nó không kịp, cho nên là cái lúc anh chạy qua nó ấy thôi, em có chụp ảnh lại rồi. Có gì tối em về em xem lại. Dạ.
Ok. Ở đây nó có hai cái vị trí, mặc dù là bỏ trong cái dấu ngoặc kép, nhưng mà nó hiểu là cái vị trí, tại vì bỏ trong cái dấu ngoặc. Cái này cũng khá quan trọng. Okay. Rồi.
Dạ cái này là
Rồi, còn cái này là dùng mấy cái lệnh bình thường ha. Okay, let's try by yourself to define the function to calculate the mean of the sequence. The mean of the sequence is the sum of the numbers, the sum of the members. What is the mean of the what is mean? Mean the average. Okay, average. 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, divide by 6. Here is the average, the mean. Okay, 3 minutes for define the function to calculate the average of the sequence. Actually, we don't need to define any function to calculate the mean, because Python also support the function that we can calculate directly. But we want to understand some basic function used for this model. Yeah. So we need to define. Calculate mean. Define function like this of the numbers of the seven like this. Okay, you can try. And then next step is we have to calculate the length. Right? So we have to calculate the length. Okay. Now we can calculate the length is. Length is measure how many numbers here. After numbers like it. And we will calculate the sum. We use sum. Maybe we can use S for sum of the numbers like this. Okay. And now we can calculate the mean. Mean is S divided by N here. And we return here. Return the value of mean. The output of the function will show the mean. We show the mean. The value, average, yeah. So now we can use it to calculate. Now we can put some average. Average is, we call that function for sevens, for x, right? S and print mean. Mean we can put in the first position. The first column is 0 here, and the second column is put in the box. The second one is number 1 here. Format. Format is the corresponding to the position. The first column is maybe say x, the 7, and the second one is average. Yeah. Okay. I found it. Okay. You did. Is there anyone create the new one different from me? Actually, we can use this function to calculate the mean of the function, the sequence. Python also supports Python. The library, I think, where's the library? It's statistic, I think. Okay, statistic library. Yeah, Okay. Well, we can use this way, import statistic and use mean to calculate directly the average of the servants. Okay. This is the software to calculate the mean. Okay, next value is median. Median is well, we also the pattern also supports the function to calculate the median of the servant. But you can understand this to use some basic function like this. Medians, we use length sort by decreasing or increasing. You have to sort it and use the function integer here, and we have to get the numbers at the position. For example, for the array like this, for G, 50, city. So pattern will calculate fit is the first one, and here the second one. No. Pattern will calculate is the 0. And here is the first one, the first element, the first member, and number 2 we calculate. But for lysing, they will calculate the one. Okay, remember that. Okay, this function you can try the arm. And also mod of the servant. For the mods of the servant, we have to import a counter to calculate to count the numbers of the servants. And most command. What is the most command? Most command function is will list this number. Will list the frequencies of the number. For example, number 1 is appearing 3 times. Number 2 is appearing 2 times. Number 3 appearing 7 times. Here the most common. And we will get the numbers right. Here's the number right. Why we put 0 and 1? What does this mean? Because the most command will return the output, will return the servants like this. For the numbers appearing which the frequencies iterated. For example, here in number 3 is 7, the first one. The array like this. Number 2 number 1 is 3, appearing 2, and here is 2. Like this. Okay. And number rect here, the most common will get the first one. The first one is 0. Here is the 0. The first one is 0. And number 1 here is number 3. That's the number 3 is the mod of the servants 1, 2, 3. Number 3 because it's the frequencies of number 3 is the greatest number. We also use the num append. Okay, it's okay. And here is the idiom of pattern. Idiom of pattern. If name, and we don't need to define the the word name and don't need to define the word main. And we can calculate that the idiom of button. Okay, I think you can try at your home. Okay. Now, so important now is the logistic. Now we will use MATLAB library to calculate to solve the model. It's called the logistic row equation. Here is the first derivative. So now we can try this. Okay. The function of here is dp divided dt here equal k p m minus p. Okay. P is the population at time t, and K is control rate, and it's also a constant, and M is the maximum population. We will use this model, and we can define the function. We can define the function to solve this model. Okay, now we can import. Now we use the import. The new function is Sabi library integrate. From Sabi, from Sabi. Interact, we will import ODE int. This function is for solving the first derivative. It's Sabi.
Chữ from á.
Okay. What is Sabi? Sabi library here.
Chỗ chữ from á thành chữ form á.
Sorry. I'm gonna go. Yeah, it's Sabi library. Abram. Okay. Interact no R, right? Okay. Sabi library, here is the Sabi library. You can follow, yeah, some function here, the document here. Can follow this. We can set ODE int. Okay, here ODE int here. Function for solve a first derivative. Okay, we can use it. We can try now. We can use it. Maybe you have ODE int. If we show some example that we can use it for it's interesting here. ODE here. We can use this function like this and some variable. Okay. Okay, now we can define it. F logistic. Now we can use logistic function here. It's the same. The input values is P, T, K, M. We can put dp, dt, is K multiplied by P by P minus M.
M minus P.
Will return the values of dp in dt, dp dt. Now we can use this function to calculate, to perform, to show the model, to show the performance of the model here. Now we can put here P0
Integrate is a system of ordinary differential equation. Note for new
first
class,
one is for P0
based
here,
on IVD to solve a differential equation.
and
Solve
the
a
one
system.
and T. T is link space. If link space we import, so we use NP link space.
Yeah.
We have to call
Nghe nè, alo.
link space here, 0 and 10.
Okay.
From 0 to 10. Well, we usually use link space to perform the graph. And K we can put maybe 0.1 and M is 10. Now we will call this for all the int to solve this model logistic model with the value of P0 here is T is, and the arguments we can put for the constant here. They are human. For value K and M. It's cannot somewhere. ELT plot. Plots will plot T and P, and we can set BLT X label for time difference one time. See, here is Y level for the population. And we can put legend. Can see like for example, and title. Title is a population row. Okay, and POT show. I put in simple cost. Okay, here is the performance of the model of with the first derivative. You run it. Okay, now here is the second derivative. How to solve this? The second derivative. We also use ODE function, but the ODE function is usually used for the first derivative. Now we will use ODE for the second derivative with the equation here. And the S square, it is square. S is a function. Let's see the SVT. Plus Kx equals 0. Now we can use this by setting the first derivative is v. First derivative is v. So y number one we can split into two parts. Is the first one is the function x, and the second one is the derivative of x dt. And we get here v. And corresponding with the first one is the first one and the second one is initial condition. So it will become the s and v. Now we can get the derivative of y. So we want to turn the second derivative, second order derivative to the first derivative. Here is will become v. Now is v will become the is the first derivative, and we will move this to right hand side here, minus c, and the first derivative will become v plus ks divided by m. Okay. Now we turn the second derivative to the first derivative here. Okay, now we use ODE to solve this. We also use ODE int the function, so we can define the new function for them function. The input value is y, t, m, c, k, and what will we do? Number y is for the first one, so the input of y is to the array of two variable here, up to numbers. The first one is x, the second one is v for the input y. That means the initial condition of the equation is setting two value of the numbers, two values of number here. It's called the initial condition. So now we will calculate it by the equation that minus c cv plus k x and divide by n. And we will calculate dy dt return the NP array. We can put in array VA to make sure this will return the two value. We'll calculate two value of V and 8. V and 8, yeah. And we'll return dy dt. What is forgot comma? Okay. We return two value of dy dt. Dy dt is the array of two number. Maybe the first number is the value of x, of y, of x, and the second is the second derivative. Here is the, for example, here is x and here is v. V is the second derivative, and if a become the first derivative, number v will become the second derivative. Okay, now we use it to, now we call the function to put here is y0 or y0 is the array of 0 1 0 and t, maybe it's the np and in space around from 0 to 5 200 value, so many numbers between the interval 0 and 5. Okay, and mck corresponding the value of 0.5, number 1 and 50 corresponding to the mass name and string constant here. Okay, now we call this function to solve this. With the initial value here is y0 here. Y0 is the input value for initial condition, and t here, and the argument is the component of mck. Now we can use plot plot. Plot. How to plot it? Because the output of y, is the array. It is the array of two numbers a1 and a2. So we have to plot for s or t. Okay, and for the number y, we will get the first one, the first column. We will get the first column. This means the first column and the first number 0. Okay, and here is PLT X level. We can set this name is time and PLT for y level here is function. And PLT so okay. What happened if we change here number 1? We will get the second column, right? The second. Let's try if we change to number 1 here. Okay. We also can draw everything on the same graph. Okay, yeah. Can we come to the next system of predator and prey? Okay, let's check. Predator and prey here is the simplest one. Now science direct. Let's see how many papers published with this model. Predator, right? Then we read. Try this. It's so new. Oh, now it's meant to fractional derivative. I use lab here. What is the model here? Stability here. Then this one's okay here. Here's some model, some new model for predator and prey, like cat and mouse. Okay, how to solve this? How to solve this model? Can you make the function to solve this? ds dt. What is the predator? Si minus p is a constant sy. You think what is the predator and what is the prey? Dr. Trương. You there? S or Y? Here is predator, right? What is the predator and what's the prey? Do you think? That's model. Do you think S or Y is predator? Dr. Cường. Are you there?
Sorry, I'm trying to think about it, but I'm not sure.
Yeah. A is the rate of increasing, right? The rate of increasing of X minus sy. Sy is, for example, cat and mouse, they eating together. So they have to minus. It's decreasing minus this. And here is the rate of, but eating, when eating will increase for the second one. So do you think here is predator, right? Here is predator. Because they're eating together will increase the population of the animals here. And here is prey, right? Okay. So now we can use ODE int or son IVB. Okay. We can use another function to use this to solve it. For the function, we can use ODE int to solve it. Okay, here I will explain to you here. Can you define the model? Can you define the model for this? Can you define the function? Okay, we can define the function for predator. Predator, right? The input value is y. That means to the component up to a number. And T I P B Q Enough. 1, 2, 3. Okay. For the input values of s and y, we can put for number y here, and ds dt is the array of x, sa minus p or beta, I think gamma or alpha. Okay, we can use p x y, and the second equation is dy dt equal minus b multiplied by y plus q x y. Here is a b and b is the rate of changing of the population of predator and prey. Okay, and we will calculate dy dt maybe NP rate. We put like this to make sure this is the array of two values, dx dt. We can put in here, and we'll return dy dt. The first one for the s dt and second one for dy dt here, and we'll return dy dt. Okay, here is the definitions of the new function. Okay, and then we can put in the links by like that. We also use the function for setting the first one in initial condition for x and y. For the second one is for predator, I think, and the second one is for prey. Okay, and t also from 0 to 80. How many numbers? 200 number, and the argument here we can put here the same way for the model, and here is the icon to show the model. I'm not sure this can run. If you have any error, let's inform me. Okay, and here is the model for the DC here, maybe a COVID flu. Here is the simplest forms of the COVID flu, is the symbol model of the flu. S represents for susceptible, and I is an infected case, and R is for the recover case, and the model of this could present like this. The function, could you make the function for this? How to make the function with the variables, with the continuous function, continuous variable. So now the first one, the first step, we change to the district numbers here with tn. Change to the derivative of tn represent for, it look like district number, and then follow the definitions of derivative. We will change to dt, follow the definition of derivative. We will split this into the section of discrete value, And we will use this to define the function. Can you define the new function for this model? Let's check, is there anyone use this for the new model? Is spread. TC. Okay, no, we can use SIR model. SIR model, simple one. Okay. It is the COVID model. Let's see how they complicated. So complicated here. SIR. Then the simpler one. Okay, many. Now we also change to the rational order of this. Okay, here. Now they put a rational order here. This maybe some variable they will put inside like this SIR here. Okay, now we can check. Now we can define this function for this model here. Sn minus Sn minus, okay. You remember this? Now we will use zeros. With also maybe I think we use a new one. We also import the new one here is import from, we can use this way to import zero and linspace, and we don't need to call np again. From numpy import zeros is the array of the number and linspace. Okay. Now we can set some constant of beta. Beta is p. Beta value. The first one is 10. 10, that means 10 recover of 40 susceptibles. Of 40 susceptible here can divide by 40 multiply by 8. I infected in one day, 24 hours. And the gamma is variable with 3 recover are there, recover are there, and 15 infected, 15 infected case every 24 every day, 24 hours. Yeah, okay. And DT, why we said DT? Because we come to, and here is DT. Here is DT or delta T, delta T here. We will change to the right hand side and we put it is 0.1. Or 1, that means 3 minutes. 6 minutes. 6 minutes. Okay. 1.1 of a city are 60 minutes. So it's 6 minutes. We will set for the 30 days. 30 days. And NT. What's NT? We will use the function int, in which we return the integers of the float or a decimal. We return the value, the integer of the number d multiply 24 divide dt. NT also is linspace. Now we don't need to put NP. We don't need. Instead, put here in NP. We don't need now. So it can come linspace. Linspace because we import. We also import zeros and linspace like this. So we just connect in pipe from 0 to NT multiplied by dt. It's in the interval of the population, the big number. Okay. And how many NT numbers? NT plus 1. The 0x is the susceptibles. Here is the 0. 0 is the arrays. Arrays NT plus 1 here. And infected A, the zeros of NT plus 1, 2, and R is a recover here is a 0 of NT plus 1. We can put initial one. Initial one is for the new case. Here is the new case, and we estimate it. Estimate for new case. And here's we can put is 50. 50. And R is a 1. And R is 1. R is 0, for example. Okay. Here is some constant we can put here. Now we made the function to susceptible here. We make the equation, some equation like this. Let me check. Because this here, the function here, we use we change to from continuous function to discrete function with n, with a discrete number. Sn plus 1 minus x. Okay. We can put here the position n plus 1. We'll calculate by Sn minus dt beta value x with x and multiply by I n. Okay, we can put it. How to understand this? So we have to put in the left for n in, maybe we put a range of nt. And for the I value is n plus 1 equal in plus dt. Here is beta, I think. Beta here s n multiply by in. Minus dt gamma in here, okay. And R for R recover case. It's called the inductive here. That's dt gamma multiplied by in. And for dt and okay, now we can put for pick BLT here. We can draw it. And what is this? We can plot I1. This is I1. How we can plot here? At 3 and BOT. It could run out of the log here. For T X I what is the value? TS is TS and TI and TR. We will draw three graph at the same time. 3R here. Now we can use legend, like make it marker. The first one is the component of I1, I2, I3, and the second one is S, I, R. and we can use the optional condition here, upper line, upper left, or we don't, we can ignore it. And POG is X level. Hours. And remember to PLT show. Oh, we put under the left. We can stop it. We can jump out of the left here. Okay. Okay, here. Here the performance of the model, DC model. For the next one is more complicated with the exposed case. The exposed case. Okay. In this model, we also use the new one for SON IVB. We can find it on Sabi by SON IVB. It's interesting of SON IVB. It's also the same function. This can solve the first derivative. There also gives you some example here. SON derivative, SON IVB. Also, you for SON the model, decay model. Initial exponential decay. SON IVB also the same function with ODE int. Can use it. I think is for reference, and you can try in your computer. Okay, is there any one new? Okay, no problem. This function is used for SON T. Maybe will have to, for example, from import from Sabi interact. Import SON IVB or BVB. Okay. We can use have to check it. Here is the use of this function here, and they define the variable like this, the function like this, and we return the values is the array of the sequence here. And after that, we use this function for SON IVB here. With the input value is initial condition with the array of the value. Maybe that they will split into 2 columns. Here you can see this 10 to here they put here value from 0 to 10, and here is 2.8 2.8. We perform like this. You can change the function, follow your working. And after that, they call it for this function and the input value. Okay, the same way. Try to understand this model because he's the first rate of susceptible. Susceptible is minus. That means this value is turn to expose. How to get the exposed value? Exposed value will come from this. This will minus because some susceptible could turn to exposed, but these values, the exposed case will receive it. But and they also minus some values of the rate of changing by decreasing. They could change to infected values. Here is the rate of infected. We increase the case of infected, and they will decrease some value for recover. But for recover, they will increase the values of this. Here the simple one for the function, for the model. Okay, you can try this by yourself. Okay. If you can see any errors for the coding, let's inform me. Okay. And next one is less square method. What is the less square method? This also used to calculate the focus of the members of the data, how to find the best fit line like this. The less square method. The purpose of this method is to minimize the distance. They try to focus on the members here on the line, on this line, and they can find the best fit. Here is the distance, and here is the line, and here is the formula of this line, the formula of distribution. Answer like this. For we have to define the means. Yeah, we have to define the function to find the least common. It's also easy, I think. We just put the new library for NP, and we return the beta and beta 0 also. Let's see, is there anything new? No, nothing new. Okay, this equation for the original function, the primitive function, and here is the second one for guess, for predict. The second one for predict. Okay, you can try your home to understand this. And now we can plot it. Okay. And next thing is how to load the notepad, how to load the data to process, to estimate, to use the function. The first one you have to define, and the next one you have to load the data. I will send you the lot. Just 1 minute. I'll send you the data for this, and you can upload on your computer. What is it? Where is it? Here, weather. And also the new one is salaries. Okay. Okay, I will just send you the data to import it. Now we can use it to make the repository here, to upload this, set the one here, basic weather here. Here's the data for weather TST. Okay, now we can call this weather by import run numpy import plot. Here is plot tst. Okay. And now we got the data by condition not tst. The name is weather. Weather is tst. We can put the condition for the time into skip row and we can skip it. And now we bring the data. Oh, anything. So we have to put a condition d time. D time is int and skip rows. Skip row 1. Okay. Okay. Here the instruction in the information of data. Okay. And we can call this data and we saw this. The next one is red image. For this one, you can try on your computer. Now I want you to use this salary CSV. A salary, now we can import it. Salary here. Okay, you got it. Salary CSV. Now we can use it to process the data, to perform the data. We can put the new one is FDF by PD. Oh, we use the name library for DP. So we have to import pandas. SPD. What is panda? Panda library. Pandas library. Pandas here. What? The Python. Okay. Here did some tutorial here for Panda basic. Here's some reference. Now we call it to call the data DF by PD. PD is the nickname of Panda library. is PD, so we just go on PD and red. Here is the type of CSV. Okay, red CSV. We can put the names here, salaries dot CSV. CSV or Excel. Sometimes so. And we count it. Now we can check this by use this df that will show the first five rows of the data of the salary here. First five row head. We can use tail to check the last five rows. Yeah, the interesting. Now we can use this right. We can summary the information of the data. Summary existing mean standard deviation, mass, average. Okay, and the first quartile, second quartile, and third quartile. Okay, we can check the info of the data here. Okay, is it in 1 0 2 3 4 5 child? How many? The size here 1,500 entries, 1,500 rows. Okay. And then now we can do it. We can check show the performance or select some rows. Select rows. DF by the new one. DF location that you want to select some columns. Want to choose the column of year. Here is some column here. We can choose. No year. Is it? Okay, a year. If year equal 2000. Is there anything? Maybe I will check why. 2013. And the ID we will get. We select ID. ID, is there anything? Is there any column ID here? Okay. And here. And what's next? Total benefits. Okay. And copy it. Make sure it's right. And DE. There any error? Locate the F year. The setting. So we have to put to equality like this. Okay, here is the new data. We can extract, select three columns of this, and we also we can draw it by we can drop it the graph. Here is the instruction will appear after the command. We can choose columns into the columns to wrap. Maybe it's ID, and we can choose the renames of the columns. Renames of the column by another name here, so we put in brackets like this. So it is total base. Where is the total base here? Maybe we change this name, total benefits. Total benefits by another name. The new name is total salary, I think. Now we can show this. Yeah. We also select some new column, new data, which is like, okay, and here is some group by. You can group by here. Group by, and you can wrap with NSN. Okay, NSN is Seaborn Larry. Okay, we have to import the Seaborn Larry here by NP. Import Seaborn by NSN. Okay, you can try this at home. And you can use subplot. Okay, many guys are also. Is there any problem with these comments? Please inform me. And here's some reference and the link for reference. I think today is so many problems, many things to understand. Okay. And here is the homework. Where you make the function that we can apply for the solution performance using the paper in recent 5 years. Okay, I think today is enough. Is there any problem?